on Friday, you still need to know. Didn't write it up here because I'm going to have you tell me the parts. Last term is equal to first term times the number of terms minus 1 times the difference. And you guys each, well, we'll start with Robert. He gets to tell me what a sub 1 stands for.
The first number in the
First term.
yeah, first term.
Okay, Nathan, what does N stand for?
The number of terms.
Number of terms. And what should always be true about it? Shouldn't it always be a positive whole number because you're counting? So you aren't going to have half of a person, for example. What's D stand for? No.
Oh yeah, different.
And how could we find it if we don't know the difference?
Take the last term minus, or second term minus first term, third and second.
And so forth and so forth. Okay, and what's a sub n stand for, Nicholas?
The term it's like
Okay, so the nth term, or last term if you prefer it. Now we're going to be using this formula again today, but we're going to add one to it. And it's going to be the sum of an arithmetic sequence. Which, isn't everything in here already been repeated? What's n stand for? Number of terms. A sub 1,
First term.
a sub n, the last term or the nth term, and s, of course, is going to stand for sum. Now, this next part you don't need to write down. We're going to look at how this formula was developed. It was developed back in the 1860s. And who was educated back in the 1860s?
The rich.
And,
Teacher.
well, the clergy. Back then, a lot of monasteries provided education for the wealthy. So it was usually the clergy and the rich that were educated. And there was a young boy, he was 9 years old, his name was Carl Gauss, and he was wealthy. So he was being educated by the monks. And the monks gave him an assignment, and the assignment was to find, this is at 9 years old, remember, to find the sum of the numbers from 1 through 100. And he's a typical, I would say, high school student. He may be like Nicholas in the fact that he liked to get his work done, but he'd like to do it with the least amount of work, with the least amount of effort, okay? So he was already at that age. So he deliberated, you know, he thought about it a while, spent more time thinking about it. Everybody else has already started adding the numbers. And he wrote it down even, and he thought about that it's 1 to 100. That can't be too hard for a nine-year-old to do, right? And then he thought about it, he thought about it. He couldn't think of a way to get it done quicker. So he said, well, if I'm going to have to add these, which he knew he was going to have to, he figured he'd start with the harder numbers first, which was the 3-digit and the 2 digits. Everybody agree with that? And when he did that, he saw something. See if you guys see it. Well, I'll give you a little hint.
Add to 101.
They all add up to 101. And to the surprise of his teacher, he knew what the answer was. He just took 50 times 101, and that answer was 5,050. And he told his monk teacher that that was the answer, and the teacher was kind of astounded that he had the answer so quickly. And you know, as an older adult, he could have easily have taken the credit for the formula, but he helped him write the formula in more form that could be usable for you guys later. And if you saw, we added the numbers from 1 to 100 twice. Do you guys see that? When we only had to actually do it once. So that's why he took the number of terms divided by 2. So he divided it by 2. So that's where that 50 came about. Then he took the first number plus the last number, which is 101, and that gave us the sum. So that 9-year-old is the way I think of it, and I always tell my students, if a 9-year-old can come up with the formula, you guys can certainly remember it. Okay, so what we're gonna be doing, now you can write down some examples. You had your little history lesson. And this could be written many different ways, but this is one of the ways it could be written. You've got the sequence 4, 7, 10, and I want you to find the sum of that sequence for 20 terms. Okay, so what do we have to know in order to be able to use the sum formula? You gotta know the first term, which is 4. You gotta know the number of terms, which is,
3.
no,
20.
20. I've gotta know, well, I don't have to know the difference, but we can go ahead and tell me what it is, right?
3.
It's 3. But what else do we have to know? The nth term. In this case, the 20th term. Do we know it? No, so we have to find it, right?
Yeah.
So don't we have a formula that can help us find it?
Mm-hmm.
So now we're going to use that formula. So the last term equals the first term, plus the number of terms minus 1 times the difference, which is 3. So what do we have to do first, according to order of operations, Spencer?
Subtract the 20 minus 1.
You get 19,
Yeah.
and then what?
Multiply the 19 by 2.
57? And the last add 1, or add 4? So we get 61. Now, so anytime you've got a problem that requires you using the other formula, I'm giving you a point for finding that. Okay, so make sure you're showing you all your work, because a lot of points aren't just what the sum is, it's what else you have to do to get there. So the sum is equal to, how many terms are there?
1.
Divided by 2. The first term is,
4.
the last term is, so 20 divided by 2 is 10, and 4 plus 61 is 65, so my sum is 650. Okay, next example, I'm going to write it looking at just a little bit different. I want you to find the sum of that sequence. So the first thing we want to do is start listing what we know. So Josie, what do you know?
The first term is 12.
First term is 12. Do we know how many terms there are? No, we don't. Okay, so do we know what the difference is? What would it be, Adler?
It would be,
16 take away 12.
oh yeah, sorry, I was trying to do the last number, okay. 4.
Or it could be 20 minus 16. So take whatever two that are besides each other and subtract them. And now, do we know the last term?
Yes.
It is. But what are we missing that we have to have in order to find the sum?
Term.
The nth term. So can't we use our previous formula again to find the nth term? So again, that formula, we know the last term's 108, the first term is 12, we don't know how many, but we do know the difference is 4. So let's see, Tatum, what would we do to solve that?
We distribute the 4.
Okay, so 12 plus 4n minus 4. And then what could we do, Marilyn?
Combine my terms, so 1 equals
8,
plus 4.
and then Riley?
Subtract the 8. Now I have to equal 4.
So n's gonna equal 25? So now can we find the sum? What do we have to know in order to find the sum? Number of terms. It's always divided by 2. First term is what?
12.
Last term?
108.
Okay, so what's 12 plus 108?
120.
120 times 25 halves I'd always do fractions. I know you guys have calculators that do it for you, but 2 cancels 120 to 60, and then all I have to do is take 60 times 25. Yeah, here, 1,500? Anybody else get 1,500?
That's already.
That's okay. One more example.
Oh, I didn't get that.
I'll wait till you get there. And while we're waiting for him to get there, does anybody know what that stands for? E. It stands for sum, but what is that? Isn't it a Greek letter? What's that Greek letter called? Are you guys cheating? Sigma. Where have you seen that before now?
Right now?
Sororities, fraternities. You drive in Pittsburgh, Kansas, or around Joplin, Missouri, around their frat houses and the sorority houses, they have those Greek symbols, right? So sigma does mean to sum. And I'm only going to have us do a short one here.
Oh, God.
How do you write that?
It's just a, looks like a big E, only it's Greek.
What
Now.
What you put on top of it?
I have 6 up on top. So the key on using a problem that has sigma in it is to know how to read it, right?
Yep.
And we've got to be able to identify all these parts again, don't we, in order to be able to use our formulas? Does everybody follow what I'm saying? First, let's describe what sigma does, and then we'll go back and we'll look at what we're trying to find. This says, this is my formula, and I'm going to be finding the sum of the numbers from 1 to 6, when n is 1 to n is 6. So the first thing I do is put 1 in place of n. So 3 times 1 plus 2 is 5. Then I put the next number in. What's the next number after 1? 2. So 3 times 2 plus 2 would be
Well, I don't know what
8. Now what's my next number after 2? So I put 3 in. We did 1, we did 2, now we're ready for 3. 3 times 3
9,
plus 2.
11, 12,
Now we put 4 in, right? So 3 times 4
12,
plus 2.
14,
Then we put 5 in.
15 plus
3 times 5 plus 2, and you should see a pattern. And the last one is 6, right? So that would be 3 times 6 plus 2 is,
20,
and you should have seen that we're adding
3.
3 every time, right? So it is an arithmetic sequence, right? Isn't that the definition of arithmetic sequence? You add the same amount to get to the next term. Now, what do we know from this?
The A1 is 5, AN
How many numbers are there?
6,
We can count them, right? What's the difference, which we'll go ahead and say?
3,
And what's the last term?
20.
So do I need to use the other formula? Nope. We can just go ahead and straight to the sum formula, can't we? Because we have everything we need. So sum is equal to the number of terms divided by 2. First term is 5, last term is 20. So you have 3 times 25.
75,
5 plus 20 is 25, and 6 divided by 2 is 3. So 3 times 25 is 75. Now, those of you guys who got your calculator, could you have added those to find the answer? Remember, common sense is something you could use in this chapter. If I add 5 and 8, 13, 13, 11, 24, 24 and 14, 38, 45, well, is it 55, and then 20 would be 75? Is everybody good following that?
and all the big ones.
Okay, now, let's do another one. And this is called the expanded form of sigma, by the way, where we list them all. And this could be N, it could be K, it could be J. It's whatever letter they want. but I'm using n just because I like n. Let's go to 25, and let's make it 4n minus 5. Now, what's our first job for sigma? Put in 1, right?
Yep.
4 times 1 is,
4,
minus 5 is,
-1,
then we put the next number in, which is,
2,
4 times 2 is,
8,
minus 5 is,
3.
then I could keep on going, but think how many of these I'm putting in. A lot, right? What do I need in order to get the sum formula taken care of? How many there are? I need the first and the last. Well, can't I go ahead and go to the last
Mhm.
Yeah.
by putting 25 in place?
Mhm.
So what's 4 times 25 minus 5?
95.
So now I know the first term is a -1. The last term is 95. I know the difference is 4. Do I know how many there are?
25.
Why would there be 25?
Because 25,
That's
how much they are?
Now, what if this didn't start with 1?
Then you have to subtract.
You'd subtract it and add 1, right? So you include the number. 25 minus 1 is 24. Add 1 to include the number 1, and that would give me a total of 25. Everybody follow that? Could I have also used the other formula and solved for n?
Can we just look at the top number on the thing?
Well, that's why I said you could, but what if I changed the bottom number? What if I made that an 8? So it won't just be the top number, it'd be 25 minus 8 plus 1, right? So it'd be 18 numbers? You guys see what I'm saying there?
No, I do not.
Okay, I'll show you here in just a second. I'll show it with the smaller one so I don't have to list them all. Okay, so we have all this figured out. Now we're ready for the sum. Sum is the number of terms divided by 2. First term's -1, last term's -5.
I think
95 I meant.
Yeah.
I wrote it, I just didn't say it. So 25 halves times 94. Right, -1 plus 95. And now 2 cancels 94 to 47. So what's 47 times 25, somebody?
1,175.
1,175? Everybody agree?
Yeah.
Okay, now this next one you don't need to write down, but I'm going to show you what I'm talking about. What if I said n equals 6 to 10? And it's 2n plus 1. We'll do something simple. So I put 6 in first, right? So 2 times 6 is 12 plus 1 is? Then I put 7, 15. And I know the last term would be 21.
Mhm.
So the first term is 13. The last term is 21. The difference is 2. The number of terms, and we'll prove this just in a minute, you take the top number, subtract the bottom one. So 10 take away 6 is,
4.
but you have to add one more to it,
5.
so you aren't subtracting the n, so that would make 5. Now to prove it, couldn't I just go ahead and add my difference of 2? 17, 19, and then I'm at 21. How many of them are there? 5. So that's another alternative, is you take the upper number, subtract the bottom, but always add 1, because you don't want to subtract that last one.
Why is
Yeah.
it, why is it not included in the 10?
Why is what?
Why is the last number not included in the 10? Like, 10 minus.
Oh, minus 6, because you wouldn't be including the number 6. If you're counting how many of them there are, you're just subtracting 6 from 10. When I want to actually know how many numbers are between them. Okay, so our sum is number of terms, first term plus last one. So what's that? 34? 2 cancels 34 to 17. 17 times 5 is 85. Does everybody agree with that?
Yes.
Now, one other example you don't need to write down. I think there's a few at the first that give you this. And all it asks you to do is find the sum. Do I have everything I need to know?
Yeah.
Yeah, so some of the problems require both formulas. Some do not, like the sigma wouldn't require both formulas, but this would be what, 15 over 2 and 5 plus 40? And that doesn't cancel, so I end up with what, 15 times 45, whatever that is,
60
somebody?
over 2.
What was it?
Oh, never mind.
675 over 2.
And then what's 675 divided by 2? 337 and a half. And that would be our sum. Is everybody okay with the sum situation? Okay, so if you look at your book, we're doing 15 through 26. Every one of those gives you some information. Some of those we require both formulas. So both formulas on some of them, not all of them. Then I had you do just 30, 32, 34 and 36 is where we get the sigmas thrown in, as well as another one that's a little bit different. So 16 through 26, find the sum, show all your work, because if you have to use the other formula, I'm also counting the point you get from getting that as well. Does anybody have questions on what we're doing?
Which ones can we use both? Or-
They're all mixed up in there, Nicholas. Some of them, not at the very first, I think 16 and 17 you won't have to use both of them. But there'll be some that you'll have to use both of them because you'll have to find the last term in order to be able to put it into the sum formula. Any of them that don't give you a sub n, you're gonna have to use both formulas. Okay, do we have questions? Okay, then somebody get the camera. And then let me see your first few.